Namaste. I am Dr. Bharat Haridas Aital. Today is the first module where we will be looking at what do we understand by geographic information system. When I say geographic information system, this particular thing will look at a technology. There is a technology that is driving the geographic information and how the systems work. So first let us understand what do we mean by geographic information technology. The second thing what we would look at is the spatial analysis. So there is a difference between a geographic information system and a spatial analysis. So let's understand what do we mean by analysis, what do we mean by science, and what do we mean by system. Then the next thing that we would look at this point of juncture is GIS as a platform for analysis, which means how do we use GIS for analysis. The last thing that we would look at this today's lecture is what are the hardware that you need where if you want to use GIS in any of the applications that you may need. So that's a very important part. Without hardware, the GIS cannot be used in more effective manner. So that would be the last part. We would look at that at the end of this particular class. So let's look at first what do you mean by geographic information. So let's say most of you would have used Google Maps, yes, or maybe some of you are travel every day with using Google Maps. So Google gives you information about where you are. Where you are is nothing but a geographic information. Or for example, let us see that most of your if there is a letter that has been sent, or if there is some maybe a parcel from any of those services that you get, so the parcel reaches your house or your office only through just with a pin code. Why is that? Because it is a geographic information which is the information about a place on the earth's surface. So if I say 72130 is the pin code, so it means to say that it is an Indian Institute of Technology, Kharagpur. So that is actually the geographic information. Geographic information gives you the knowledge about places on the earth's surface. So it also tells you what is the knowledge about where something is, which means to say that if you are locating an object, or let's say let me give an example, something like this. Now when you do a speed post from maybe from in India Post, so it gives you a specific EWB number. So that number, if you can track it on the web, you can know where the post has reached. It may have if I have posted from Kharagpur to reach Mumbai, so from Kharagpur to Kolkata to Mumbai post office and to that destination address, it gives you every update of where the post is actually reaching on. So this is exactly what is a geographic location. It is saying what is something and where is something, and exact geographical location of that that particular parcel. That is exactly the geographic information. So it can be very detailed information, it can be very coarse. So it can even give you information about what is inside the parcel, what are the different aspects inside the parcel. That is a very detailed information. But if the parcel is reaching you and you need only to track it, then it is a very coarse information. So GIS has a capability to handle both larger detailed information and also a coarser, not much detailed information also. So it is upon a user's perspective that how they use this particular system. If some there may be a huge number of users who will be using geographic information system once it is designed. There may be certain part of users who may need a coarser data, some part of users who may need a very detailed data. So it depends on the user how to use this data, how they apply their data into their application fields, and how they utilize this data to get a meaningful information. So now what we understand as geographical data can also have meaningful information, which means how, that is what we are trying to learn in the course. How do we collect the data, store the data, and convert it to information, very important information that can be useful for many. Then most of the geographic information are very static. Nowadays with various technologies that has grown, though it has been projected as dynamic, but normally a geographic information is very kind of very static. And very importantly is that it is extremely voluminous. You have huge volumes of data, and this understanding this kinds of data can be sometimes very cumbersome. That is where GIS gives you an extreme edge, which means to say that it can handle a voluminous data. Let us say that if someone is trying to understand what is the urban growth in the last 20 years, if he or she has a set of maps, all the maps stacked upon one another in a physical format, physical maps. So it is very difficult for you to match each and every quantity on every map to understand what is the change that may have happened. But if someone has a GIS as a software, now he or she can easily use a query to just give you an information, just like a query that is done on Google. So that is why a voluminous data can also become a meaningful information if you have technologies associated with it. So this is actually what a geographic information is about. It gives you information about yourself, it gives information about where a particular phenomena, location, or any aspect is there on the Earth's surface, and it also tells you if it is something, it gives you details about something. That's what geographic information is. So now with geographic information, if we add technologies, when I say technologies, you have various technologies that can add value to geographic information. The first technology that you can see is geographic information system itself. So that's one of the very big technologies which can relate a system of technologies, a hardware or software assigns to geographic information. There is a technology called remote sensing which can give you the entire details of the Earth's surface without even being in contact with you. For example, when I'm looking at you, I'm teaching this course. So you are trying to understand the concept without being in contact with me. So you only look at the lectures, the lecture schedule, and the course that is being taught. So which means to say that neither you nor me are in contact with each other physically, which means you are remotely sensing this particular aspect wherever you are from, in any part of India or any part of the world that you are looking at. That is what is remote sensing. And we have global positioning system. You would have heard this global positioning system very often. So global positioning system is one of those systems which can be a key input, a key technology that drives geographic information system. So I would deal with what do you mean by global positioning system, how does it work, what are the different technologies that are involved in India's indigenous way of looking at the parallel part of global positioning system, then looking at how different data can be collected using geographic positioning system in maybe in the week 6 or the week 7 of my lectures. But let us understand what do we mean by remote sensing. So when I say remote sensing in terms of Earth's perspective or a geographic knowledge, remote sensing is using Earth orbiting satellites, or it may be even high altitude planes or a low altitude plane or even UAVs, etc., in order to collect information about images about the region, area, or a phenomena, which means that we are collecting information about a phenomena of an object or a region without being in contact with it. This makes it an extremely useful tool in understanding what are the changes, dynamic changes that are happening in the Earth's surface. And this remote sensing data is in today's context with the Department of Defense going in a very big way in developing different satellites which can capture all these informations. We have huge number of satellites which can give you information from in terms of daily to monthly to an yearly. So when we look at this entire data set, it may be very useful for everyone to understand what you mean by remote sensing. So if we can understand what you mean by remote sensing along with what is geographic information system, that can help you do wonders in lot of applications that you may handle in future scenarios. So, when we look at this, satellites data is also dependent on what details you need. For example, if someone is working on how the urban growth is happening, he or she need not get a detail which is as where a particular building is there, what is the structure of the building, what is the size of the building, etc. So, he or she can have a medium resolution data or a coarse resolution data, whereas if someone wants to go into details of a building, what is a kind of a building, height of a building, size of a building, etc., then you would have to look at something which is extremely precise, extremely very good resolution, detailed resolution. So, which means you are looking at pixel by pixel, almost closer to 30 centimeter, 20 centimeter data in a pixel. So, that is where you need to choose what kind of data you need, whether you need a specific data which is coarser, or whether you need a specific data which has very detailed information about certain issues. So, the first step, that wherever you are looking at any analysis, is collection of data. What kind of data you need, how do you sample that data, how do you get that data, what are the different sources. So, that has to be understood very clearly, and remote sensing can be one of the inputs if someone is looking at any of the earth related issues, any of the change related issues, and with the advent of UAVs, so and drones, so you can look at huge applications that can be applied in every field that you may think upon. And how does this remote sensing actually works? You have a satellite can have its source of energy or can use a solar energy in order to transmit the data. So, it uses the energy, and this energy becomes an input as a source of energy in order to use those sensors on board each of the satellites. So, these satellites collect information about the Earth's surface periodically, and this data is then transmitted to the Earth's surface, to any of the stations that are there on the Earth's surface. So, once this data is collected in the stations in the raw format, is then rectified, converted in the usable format. There are various ways of distributing the data. So, National Remote Sensing Center in India is a nodal point in distributing this satellite data. So, if one is very interested, I would please look at National Remote Sensing Center's website. It gives you a detailed information of how do you acquire data. There is a lot of data, that is all satellite data, that is available free of cost for any of the researchers also. So, I would also show you how you access this data, how do you download this data, maybe in the next week or the coming weeks. So, this is about what you mean by remote sensing. So, now let us understand what do you mean by a spatial analysis. So, when we look at remote sensing, you are collecting the data about an area, phenomena, or an object. So, now when we look at it, now you have collected a data, you have a data and a data set with you. So, in order, if you want to do certain analysis on this data, you need to do a data manipulation, data queries, or using any of the geographical information systems or science, you try to understand or make it useful in terms of what applications you need. That is exactly what do mean by a spatial analysis. That is how it is different from a geographic information system. You have a system which is used to derive meaningful information from a data, that becomes your spatial analysis. So, in order getting from a raw data and information is nothing but a spatial analysis. And people use another term which is called spatial statistics. So, spatial statistics is usage of basic and a complex statistics in order to arrive at a certain outputs. For example, if someone is looking at maybe rainfall in the region. So, if you look at the rain gauge stations in the entire region, you may have 10 or 12 rain gauge stations. It depends on where the rain gauge stations is located. I just took an example of 10 or 12. So, if you have 10 or 12 rain gauge stations and you want to see the entire phenomena of rainfall in the entire region, So you use spatial statistics, you use spatial statistics in order to derive how the pattern of rainfall is there in the entire region. For example, an image shown here, you can see that there is if you see this, there are only rain gauge stations in these points where the rain gauge stations are located. But when you look at it, because usage of statistical techniques, we could understand what is the rainfall intensity in the entire region. So that is where your spatial analysis along with statistical knowledge can help you in understanding meaningful data or have a meaningful information from the data. So when we look at spatial data, the first thing is this is a descriptive and exploratory based on a very large data set and a complex data set. As I said, GIS can handle a very complex data set, whatever the size may be, however the data may be. So which means to say that when we are looking at this complex data set, it is highly descriptive and exploratory. So the data that I may need may not be needed by someone else. So this database has to be huge, and it can be made huge by different methods and looking at how the data is acquired over a period of time. So using this spatial data, this data is basically an input to the models. For example, here in the image, when you look at this particular image, you can see this is actually image of Hyderabad. So this is a remote sensing image where you see I am trying to understand what may be the changes from the center to the city boundary. So when you look at this is a city core region, you have a water body here, these are the urban regions, and you have a vegetative part also here. So what I am trying to understand here is when you have a center core, from the center core region, how the urban density is actually changing, where the urban density is high and where the urban density is low, which means urban area, any paved, I have considered this as any paved surface is an urban area. Using a paved surface divided by the total area will give you urban density. With this, I am trying to calculate in this circle how much is the urban density. So which means to say that when we look at that aspect, it is easier for us to understand in every buffer. For example, if we take the first circle, the second circle becomes a buffer or a neighborhood. So when we look at this, we understand how the changes is happening from the city center to the outskirts of the city. So it means that it gives you a meaningful information about how the city is growing. That is what do you mean by a spatial analysis. Okay, so that is the difference between geographic information system and spatial analysis. You need geographic information system in order to do such spatial analysis. So we understood what you mean by geographic information system, but if someone asks you what is GIS then? So when I say geographic information system is a special kind of information and system. When I say information, it is the derival of information or data, meaningful data from the data that you have collected, and this can be manipulated, summarized, queried, edited, visualized, modeled. So this information in terms of usage of hardware or software becomes an information system. Now this information system is cannot be accessed by anyone if it doesn't have a geographic data, because for example, if whatever the map I did show you in the previous slide, if I would not tell you that this is a map of Hyderabad, you would not have understood which urban density map is it actually what I am looking at. So that Hyderabad is the geographic location in that particular information, whatever the information system is there. The remote sensing data is used to derive meaningful information through usage of GIS using a buffer analysis, and the geographic location is derived as Hyderabad. So this is what is called geographic information system, which means you have geographic coordinates of the earth surface locating where on earth is that particular piece of data that you have collected, then information, that is the information about object area or a phenomena or a data that you have collected, and the system that is actually capturing it, the hardware and the software and all of the systems that we use, that is nothing but your geographic information system. Okay. So, when we look at this, it uses a special information about what is where on the earth's surface. That is what I explained in my last example. A system for input, storage, manipulation, output of geographic information is nothing but a geographic information system. So, from today if someone asks you what do you mean by a geographic information, it means a geographic information system, it means to say a system of input, storage, manipulation, output of a geographic information using a hardware or a software is nothing but a geographic information system. Okay. So, if we have understood what is GIS, let us understand how the GIS can be made use of. For example, this image gives you a practical representation of how GIS works. GIS, you have a data that is available, that is fed into a hardware, which may be your computer systems, which may be your mobile phones, which may be any of those systems that are available in today's world which have a computing capability. Then you have a software. In order to analyze, this software is a collection of tools which can analyze the geographic data to derive a meaningful information. Then you have data that you have already inputted into this software. Then you have different methods, different algorithms, different ways of looking at how GIS data manipulations can be done to derive meaningful information. Then once you have done these analysis to derive a meaningful information, you would put it out to the people so that the information can be used by people for various issues. That is what is nothing but the entire process of how geographic information system works. It tells you where you are, what you are, and it gives you some meaningful information about you. So, that exactly says is the entire aspect of geographic information system. And if someone asks you how does it look like, because until now we have heard it as geographic information system has hardware, has a software. Yes, geographic information system is actually a real application which includes an hardware, data, software and people to solve a problem. So, if you are trying to look at collecting data and supplying information, then it is an hardware, a data, a software, and it also has people who can actually take in this meaningful information. And GIS also can be defined as an application software. If someone has a ready data that is available and someone has to just use certain tools to derive information and pass it on, then it also is an application software. You are developing certain tools in order to see how this particular geographic information can be derived. That means that there is a second category of GIS where it may be someone who understands advanced GIS in order to look at the applications. So, that is nothing but just a software. Okay. So, when we look at GIS, it is both real applications, it is also about just a software. And if we think that GIS is an hardware, what kind of hardware do you need basically? This is the first thing that every student asks me. If I want to learn geographic information system, what are the different hardwares that are present in this particular instance, in order so that we can understand how geographic information system works. So, it is as simple as this. If you are just deriving some meaningful information from the data that is available, so you may need just the data that is stored in the computing system. That's it. You need a computer basically. So, you have data that can be either inputted through a CD-ROMs, your pen drives or any of the DVD-ROMs, etc. So, once you have put it into your computing system, you need a software which can be able to process this data using different tools that is already developed by various aspects, and these tools can be used by you in order to derive information. So, which means you need a computing system, a CPU, and you need a display system in order to display this meaningful information that you may have derived. and possibly if you have a good internet connection, it adds value into your data, because you can validate your data, you can visualize the data against the real world scenario. We'll look at all of these as examples, maybe when we look at how we do an hands-on on using QGIS. So in case if you want to do an advanced analysis in GIS, then probably you need something like maps on a very big paper. Okay, you need maps. That if you have a maps as a data, then you need scanners in order to scan these maps and provide it as an input. Then probably some of them you also need digitizers. Instead of scanning these maps, they digitize the map. We'll also see how the digitizers work maybe in the further classes. And we also need something like a plotter and a printer. So in order to print the meaningful information that has been derived. In case you want to become an advanced user, you may need all these things. Otherwise, just a computing system with the display system is good enough for any the GIS user. And moreover, if you are with now the advent of mobile technologies, probably you have the best hardware in your mobile phones itself that can be used as effective geographic information systems or technologies. So the very important part of this is how the information is stored, where are the contents of the maps and images. So if you have contents as maps and images, it may be extremely useful as a if you have a computer to process this information, because when you have images and maps, these occupy a huge hardware space, huge data space, where hence you need maybe you need computing stations in order to handle such information. And when we look at this, you have different tools to do things with the information. It may be displaying on the screen, editing, changing, transforming. So because of this, it may not be possible in any of the small computing stations like mobile to actually do it in extremely effective way. Whereas if you have a system, a computing system, it may be a laptop, it may be a any of the computers with CPU basic configuration can help you in displaying on the screen, editing, changing, transforming this. How do you transform the maps as a digital data? We'll look at it in one of the practical classes. Then how do we measure distances and areas? How do we combine maps of the same area together? So all of this can be done with using a GIS. So all of this we'll look at each of them in one practical class. Okay, so those information can be simple, it can be sophisticated. So you can keep inventories. Maybe for example, if you have collected huge amount of data of the same area on various aspects, you have a group of students who is actually collecting different informations. So they want to build up the entire database. So you have different database, you keep an inventory of the database of what is where. That once you have a database that is inbuilt and you have a geographic information that is inbuilt, it is easy for any student sitting in the lab can access this data and derive meaningful information. Then manage properties, facilities in a particular region. So it's easier for you to give directions to your local authorities in order to derive information or give them directions. Judge the suitability of areas for different purposes, different issues. So it may be now it is very necessary in order to give geographic information when there are certain things that is being developed at a particular site. So that can be done using GIS. That's why it is being used as a very effective tool. Help users make decision about places and to plan. That is a very important aspect. In order if you want to plan your city to become a green city or a smart city, you need to plan it for the future, maybe next 20 years, 30 years, 50 years. So how do you do a plan? So whatever the geographic data that you have collected over maybe past 2 decades, use it to plan it for next 5-6 years, maybe 50-60 years. Then make predictions about future. The current state is like this. In next 50 years, what may be the change in using GIS can be understood. So it has sophisticated functions, it has advanced functions, it has basic functions. It is up to the user to collect this information, to understand this how this process is there, and use this GIS as a meaningful tool. So GIS can perform a lot of part of the software. We will look at all of these as when we go through how the software works, what are different specialization in GIS, how probably how this has been supplied by a company. See, there are various companies when we are looking at GIS softwares. If you have enough money to buy softwares, you have good softwares like ArcGIS, which can give you extensive capability of looking at GIS. But let us say if someone wants to use free and open source software, you have extremely good softwares like GRASS and QGIS, which are quite competitive, which can give you diversified tools in order to understand and derive meaningful information. So you have both types. In today's context, in this particular lecture schedule, we would look at the free and open source software that is using QGIS. How do we derive meaningful information? That is what we will be looking at maybe in the 7th or 8th week of this course. So to summarize today's class, we learned what do you mean by a geographic information system, and it includes GIS, remote sensing and GPS. Okay, when we say information systems includes GIS, remote sensing and GPS. And how spatial analysis is very different from geographic information system. Spatial analysis is deriving information about a region, area, etc. But whereas geographic information system is about handling that particular data to give you or it's just a software or a hardware to give you meaningful information. Then GIS is an hardware is just a computing device. So you need basically a computing device to process the any geographic information to derive geographic data to derive meaningful information. You can have a scanner, you can have a digitizer, you can have a printer if you can afford, if you want to become an advanced GIS user. Then GIS can be called just as a software. It can be a hardware, it can be just as a software. If you are trying to develop tools for geographic informations, then it becomes a software. So the next class we will learn more about GIS, we will learn its importance and its applications. So thank you very much. Let us meet in the next class with more information about this subject. Thank you.